Welcome back, y'all. Today we're going to look at lesson 2.2, which is titled Patterns and Linear Functions. Same Common Core State Standard, a couple different vocab words, dependent variable, independent variable, input, output function, linear function. Lots of fun things to talk about today. So let's get to it. Alright, so this is in a relationship between variables. The dependent variable changes in response to another variable, the independent variable. So the dependent variable is the one that is changing depending on what happens to the independent variable. The values of the independent variable are called the inputs, and values of the dependent variable are called the outputs. So we can use these variables, and they can be represented using tables, words, equations, ordered pairs, and graphs. So we're going to look at all of those things today. So this one says, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? So our two variables we're looking at are the number of rectangles and the perimeter of the figure. Okay, now if you remember, perimeter just means you're adding up all the outsides. Okay, so if you look at these rectangles put together, we're ignoring all this stuff on the inside because the perimeter is just looking at the outside. Represent this relationship using a table, words, an equation, and a graph. So 4 things we have to do here. So let's do the table first. So I'm just going to make a 2-column table here. And we have number of rectangles, and then the perimeter on this side. Okay, so we start with one rectangle, then 2, 3, 4, etc. So the perimeter with one rectangle, well, we have 6. So that means this side is also going to be 6. And we have 1 and 1. So if I add all those together, I get 6 plus 6 is 12. 12 plus 1 is 13, plus another one is 14. So the perimeter is 14 for one triangle, or one rectangle. Okay, if I add another triangle, does the perimeter double? That might be your intuition, but it actually doesn't. Because, again, we're ignoring this piece in here. So we have 6 here, 1. Now we have 2 1s, because the width is getting bigger. The height is actually staying the same. So it just gets a little bit wider, this rectangle. So we got 12 plus 1 plus 1 plus 1 plus 1. So 12 plus 4 is 16. And then this one, we've got 3 1s here. So 12 plus 6 gives us 18. Now we got 4 1s here and a 6 over here. So we got 12 plus 8, which is 20. So writing this all out, you can kind of see a pattern starting to form here. So if you notice, every time you add a rectangle, your perimeter goes up by 2. Okay, so that's a table. Words, you can just write basically what I just said. For each rectangle added, the perimeter goes up by 2. Okay, an equation. So now coming up with an equation here, you have to think about what are we starting with, and then what's our change here. So when we have one rectangle, we're at 14, and then we're adding 2 each time. So this is actually what we call a linear equation because it's a constant change. So the width you're adding, with each additional rectangle, you're adding to the width. So we're going to start with just the height, because the height always stays the same, and that's going to be the 6 here. So the height, so our perimeter, let me fix that, perimeter, we are always going to have that 12 there, plus, then depending on how many rectangles we have, we are going to add 1, and actually we add 2, because we have the top and the bottom, or we add 2 to the top and 2 to the bottom, or 3 to the top and 3 to the bottom. So you're adding, because it's the top and bottom, you're adding 2 per each rectangle. So I'm going to say R for rectangle. And that's your equation. So if you have a 1 rectangle, you just plug a 1 in for R. 1 in right there. And then 12 plus 2 is 14. So we get 14 here. If you plug a 4 in, 2 times 4 is 8. 8 plus 12 is 20. So you get 20 here. So where's the eraser? So this 12 here is what remains constant. So that's the same throughout. The 2R, that's what's changing. So you're adding 2 for every rectangle that you tack on there. Okay. Then if you want to graph that, you can just graph it like so. So perimeter is going to be our dependent variable because the perimeter depends on the number of rectangles. So that goes over on the side. I'm going to do P for perimeter. Number of rectangles on that side. I'm going to do this little lightning bolt symbol. If you guys remember that. And I'm going to start here at 12, 14, 16, and so on. 1, 2, 3, 4. So when you have 1, you're at 14. That's right, that right there. At 2 rectangles, you're at 16. 3 rectangles, you're at 18. And so on. And it forms this, oh, man, it keeps doing that. Forms this straight line here, which apparently I can't draw a straight line with this, but imagine that's a straight line. It would form a straight line. So that's linear. Alright, so those 4 things is basically what you're trying to do today. So I'm going to let you go ahead and try this one. I want you to make the table and then come up with the equation, and then we can talk about B and C after that. So take, you can pause this in 3, 2, 1, pause. Alright, welcome back. So here is my table. I've got my number of triangles on this side, 1, 2, 3, 4. My perimeter, 10, 14, 18, 22. So you can see the pattern, they're adding 4 each time. And here's my equation, perimeter equals 6 plus 4t. And it's 6 because these 3's here are constant in all of these. And you're just adding 4 depending on how many triangles you have. Okay. Now this says, suppose you know the perimeter of n triangles. What would you do to find the perimeter of n plus 1 triangles? Well, if you know the perimeter of some number n, to get 1 more triangle, you just have to add on 4 more. So you just do n, whatever the perimeter is, n, and then plus 4. Okay. There's a couple more questions that you guys had on here from your Q&A questions. Let me see if I can find them quickly. I think it was this one. Stop. What is something everyone looks stupid doing? From L. Soakai. Sorry, I don't know if I said your last name correctly. But something everyone looks stupid doing. Vaping. Everyone looks stupid vaping, so don't vape or you'll look stupid. PSA for all of y'all out there. Also, for real though, when you have that like itch in your ear, but it's also kind of in your throat too, and you're like trying to itch your ear and you stick your finger in there and you like, everyone looks stupid doing that. But it's cool because it happens, at least to me anyway. Maybe it doesn't happen to everyone, but yeah. Anyway. All right, so I've just been talking to myself for the past, I don't know, 5 minutes. I don't know where we left off. So I guess I'll just do this again. If you've already seen this, then you can go ahead and fast forward through this. I'm not sure why this keeps pausing, but I just keep talking and then I look back at the time and it's paused. So anyway, when you're trying to determine if this is a linear function, so you look and see if it has a constant rate of change. And your x's over here are going up by 1, your y's are going down by 3. So I have the negative 3's. So to find the constant rate, we just take the y divided by x. Change in y divided by change in x. So because these are all the same, we only need to do really just one of them. So our constant rate of change is going to be negative 3 over 1, which is just the same as negative 3. Okay, so it is linear because it has a constant rate of change. When we divide y by x, they're all the same. Okay, and to make an equation out of that, we know this is linear, so it's going to be in the form y equals mx plus b, where m is your slope or your constant rate of change, and b is your y-intercept. So m, we're just going to plug in our constant rate of change for m here, so that's going to be negative 3. And then b is going to be our y-intercept. Now your y-intercept is what the y value is when x is 0. So it's kind of where you're starting at, your initial point. So if you take 0 photos, how much memory is in your camera? And that's going to be this top part here. So that's going to be 512. So 512 goes in there. So your equation should be y equals m, which is negative 3, negative 3x plus 512. There's our equation. To graph that, this is going to be a rough graph. So I'm going to start up here at 512. That's going to be our first point. That's our y-intercept, so it's on the y-axis. And then we go down 3 and over 1, because that's our slope, 3 over 1. So it's going to be something like this. I'm just kind of estimating this right now. Okay, but it should form a straight line. But for every additional photo, it's going down 3. Okay, and then this is memory. This is photos. And to describe that using words, you could just say, I'm not going to write it down, but you could just say that for each additional photo you take, the amount of memory you have in your camera goes down by 3 megabytes. Okay, so you got your graph, your equation, describing it in words from the table. Okay, and this is a linear function because it has a constant rate of change. All right. Is this linear? I'm going to give you like 5 seconds to look at this. Tell me if it's linear. And these ones are going up by 1. All of them. These are going up by 2. Okay, and then if you wanted to find the equation, we just do y equals mx plus b again. M is going to be the rate of change, so y over x, this is our y, this is our x. So we're going to do 2 over 1, they're both positive. X plus b, b is going to be your initial value, so when x is 0, y is 8. So y equals 2x plus 8. Okay, you can go ahead and see if you can figure out part b here. See if you can write the equation for it, or if it is linear. And that's all I have for today, folks. So I will see y'all on the next one. Hope you guys have a great evening, afternoon, morning, whatever time it is where you're at. Adios.